I gotta go. I'm leaving on a jet plane, and I don't know when I'll be back again. But, you know, I might just have time for one more example for you before I go. I think I'll still catch my flight. So let's look at this plane region by finding the area between the curves x equals y squared and y equals x minus 2. Now I'm going to draw my picture a little bit bigger. There's a reason for this that you'll see here shortly, but you know, the x equals y squared, let's look at that thing. If I want to solve that in terms of y, that would be, if I take the square root of both sides, that'd be plus or minus the square root of x. So the reality is y equals positive square root of x looks like this, and y equals minus the square root of x looks like this. And that's about as good as I can do, as big as I drew that. But basically it's a parabola that's rotated. We switch the x and the y, so it's a, instead of x equals, or y equals x squared here, we flip it around to y equals x axis and call it x equals y squared. It's just a parabola sitting this way here. So if that makes sense for you. So we have that. And then we have the line y equals x minus 2. And I'm going to use blue here for this. Now I'm not using red and green because I don't necessarily know which one's on top or on the bottom. So there's minus 2. We don't have to be completely exactly accurate, but we need to just have a concept of what we're trying to do here. So that's a line going through negative 2 for the y-intercept with a slope of 1. So rise over run of 1. So the reality is we're trying to get the area in between these curves here, in between the purple curve and the blue curve. The problem is we need to figure out which one's on top. Well, over toward the right here, it'd be nice to figure out which x value we have here, right? So we're going to figure that one out. And then, of course, we know we start at 0 here on the left. But the reality is, over here in this area, the purple curve is above the blue curve. So y equals the square root of x is above y equals x minus 2. However, it's going to be that way for a while until we get here. And so the reality is we actually have two regions that we got to worry about. And so I'm going to go vertical there. So to the right of that black line, square root of x is bigger than x minus 2. But to the left of that black line, we actually have two different curves going on. We've got the square root of x up there, and on the bottom we have minus the square root of x. So really we have two different regions that we're trying to figure out here. So I'm going to split this into two parts here, and I think I'll use my different colors. But I do need to figure out where this happens and see how accurate I was. So the way we can figure out the x values where they're the same is we can simply solve this here. And if I do that, let's plug in, solve this. We've got y equals plus or minus the square root of x. And over here I've got y equals x minus 2. So why don't we just set the y's equal to each other to figure out what the x's are? Because right here and right here, these heights are the same for both curves, correct? So what we need to do is figure out the x value that happens. So I've got y equals plus or minus the square root of x, so plus or minus the square root of x. And now I could have two different equations, right? But anyway, this equals x minus 2. So one thing we could do to solve this is square both sides, right? And if I square the left side, I'm just going to get x, right? Whether it's positive or negative, that'll square out. And on the right side, this is x minus 2 quantity squared, which is actually x squared minus 4x and then plus 4, right? So then if I subtract x from both sides, I'm going to get 0 equals x squared minus 5x plus 4. And then, of course, now I can factor that out if possible. Otherwise, use the quadratic formula, right? So 0 equals x minus 4 times x minus 1 is going to work here. And this tells me that x equals 4 or x equals 1. So let's do that here, and so x equals 4, x equals 1 is actually where that's going to be. So I wasn't quite drawn to scale here. It would have been a little bit farther to the right, but the reality is that this black vertical line occurs at the line x equals 1. So what I want to do is I want to split this up now. So the reality is from the origin over to x equals 1, I have the square root of x graph is the one on top, and the one on the bottom is minus the square root of x graph. So I'm going to do that one in purple here. Well, actually, let me get red and green here, since those are two colors that I don't have and I haven't missed my flight yet. So I'm just going to do this one in red. So if I want that red area, I am bounded on the right by the vertical line x equals 1. And then the area of this thing is going to be the definite integral from 0 to 1 of the top one minus the bottom one. So in that case, that's going to be the square root of x minus the bottom one, which is minus the square root of x. So minus a minus is plus the square root of x, and then with respect to x. So that's going to be the area, that red area of that plane region there. So this is going to be, I'm just going to go ahead and calculate this part. So this is going to be 2 times the square root of x. So I'm going to rewrite that as 2 times the definite integral, because the integral of a constant times a function is a constant times the integral of the function, right? And instead of square root of x, I'm going to write it as x to the 1/2 power with respect to x. And then I'm just going to simply figure this out. So this is 2x to the 3/2 divided by 3/2. So once again, instead of dividing by 3/2, I can multiply by 2/3. And so if I do that, that's going to be 4/3, right? And then I'm going to evaluate this from 0 to 1. So it's 4/3 times x to the 3/2 power evaluated from 0 to 1. Well, if I plug in 1 to the 3/2 power is 1. And then plug in 0 to the 3/2 power is 0, right? So this just ends up being 4/3 square units. So the area of this red one right here is 4/3 square units. So now I've got to figure out the area of the right one. So I'm going to use green. I haven't used green yet. So from x equals 1 to x equals 4, that one is definitely going to have y equals square root of x is still going to be the bigger one, but the bottom one that's bounding this now is actually the blue line, which is x minus 2. So that green area is going to be given by the definite integral from x equals 1 to x equals 4 of the top one, which is the square root of x, minus the bottom one, which the quantity x minus 2. So remember, I got to subtract the entire function, so I got to have parentheses around that. And so if I do this, then I can figure out what this is. So I'm gonna add the opposite here, and if I do that, add the opposite, it's going to be the square root of x minus x plus 2, and so this becomes the definite integral from 1 to 4. Let me just rewrite this, of square root of x minus x plus 2 with respect to x. So I'm going to go ahead and take the antiderivative. Instead of square root of x, I'm going to write it as x to the 1/2 power as well. And so this ends up being x to the 3/2 divided by 3/2 is the same as times 2/3, evaluated from 1 to 4, and then minus x squared over 2, evaluated from 1 to 4, and then plus 2x, evaluated from 1 to 4. So this time I remembered the proper limits of integration, because it's not the same as these, right? It's the green area that I'm trying to come up with. And if I do that, by the way, I could have just took the entire thing and evaluated that from 1 to 4. I'm doing it in pieces just so I don't get lost in some mental math calculations here. So if I plug in 4, this is going to be 2/3 times that thing. So now I'm going to plug in 4. The square root of 4 is 2. 2 cubed is 8, right? So this is 8, and then 1 to any power is 1, right? So that's 2/3 times 7 in this case. And then minus, now I got to subtract this whole quantity. So if I plug in 4, I get 16/2, which is 8. But then remember, I'm subtracting this whole thing here. So minus, because when I plug in 4, I get 8, and then minus this evaluated at the lower limit would be 1/2, and then plus, and then 2x evaluated at that. I plug the 4 in, and I'm going to get 8 minus 2 times 1 is 2. And then all I got to do is a little simplification here, right? So this ends up being 14 thirds here, because that's a 7. So that's 14 thirds. And then we've got minus 7.5. That's minus 15 halves. And then we've got plus 6. And so all I got to do now is get a common denominator. And so I'm going to come over here where I got a little extra room. So I've got common denominator would end up being 6, right? So that'd be 28 sixths. And then minus 45 sixths. And then 6 is plus 36 sixths. Doing this here, I'm going to get whatever the easiest way is, but that's going to be minus 9 over 6 from these two. So minus 9 plus 28. 28 minus 9 is what? 19, right? So this is equivalent to 19 sixths square units here. That is the green area. Right here is going to be 19 sixths square units, and then the red area was 4 thirds square units. And if I want the total area, then for the total area of all of that, I'm just going to add it all up. And so 4 thirds plus 19 sixths. So the total area is the red area plus the green area. This, instead of 4 thirds, is 8 sixths plus 19 sixths is 27 over 6, and of course that reduces now, so even though that one didn't, these are both divisible by 3, so that's 9 halves square units, or 4.5 square units. So that came up with the exact area, and I just got an alert that my flight got delayed. So what I think I'm going to do just for fun, just to kill a little time while I'm waiting for my jet plane to go on my vacation to get out of here, is I'm going to go do this a different way that might end up being a lot easier.